Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
This one question lost more marks than any other on last year's papers. Students picked the wrong rule and their working disappeared into thin air. Sound familiar? If you've ever stared at a triangle and thought, which rule do I use? This episode is for you.
Oh yes, that panic. 2 sides, 1 angle, is it sine, is it cosine? I wish someone had given me a decision map.
Episode promise. In the next 10 minutes, you'll have a one-line decision rule for choosing sine or cosine, 2 short worked examples, one that shows the tricky ambiguous case, and a 10-second substitution check that catches most errors. We'll also show exactly what to write to grab those method marks. Let's work through this step by step.
First, the concept. Imagine a triangle labelled A, B and C with opposite sides A, B and C. The sine rule links sides and the sines of their opposite angles. Side over sine of angle, written aloud as A over sine A equals B over sine B equals C over sine C. Why does that work? Because if you drop a perpendicular in the triangle, you create right triangles where the sine function connects side and angle. The ratios come from the same height from different corners. Same height, different bases. So the ratios are equal. Let that sink in.
So the sine rule is about matching a side with its opposite angle. That feels sensible. Exactly. The cosine rule is the other tool. Use it when you have 3 sides, or 2 sides and the included angle. In words, a squared equals b squared plus c squared minus 2bc cos a. It generalizes Pythagoras for non-right triangles. Intuitively, cos A adjusts for how open the angle is. If A is 90 degrees, cosine is 0, and we're back to Pythagoras.
Decision rule. A short version you can memorize. If you have an angle and the opposite side, a pair, and another side or angle opposite, reach for the sine rule. If you have the included angle between 2 known sides or all 3 sides, reach for the cosine rule. Now I'll show 2 worked examples so you can hear the exact lines you should write in an exam. Worked example 1, sine rule, opposite angle problem. Question. In triangle ABC, A equals 7, B equals 9, and angle A equals 30 degrees. Find angle B. Step 1. Write the formula you are using. I would write, by the sine rule, sine B over B equals sine A over A. That's a method mark. Write the formula. Step 2. Substitute. Sine B equals B times sine A divided by A. So sine B equals 9 times sine 30 degrees divided by 7. Sine 30 is 0.5, so that's 9 times 0.5 over 7 equals 4.5 over 7, which is 0.642857. Step 3. Take arcsine. B equals arcsine of 0.642857, which gives roughly 40 degrees. Write your working. B approximately 40 degrees.
That's straightforward. But isn't there another possible angle when you take arcsine?
Good question, and that's the ambiguous case I mentioned. When you use the sine rule with 2 sides and a non-included angle, the SSA case, sin B could correspond to an acute angle or its supplement. So after B equals arcsine of 0.642857 equals 40 degrees, you must check for a second possibility. 180 minus 40 gives 140 degrees. Both are mathematically possible. You must check the triangle context. If A is 30 and B were 140, that leaves C as 10 degrees, which is positive, so both triangles are possible. If the numbers made the sum exceed 180, then the second option would be invalid. Write both possibilities or show your check. Examiners want to see that thought.
Worked example 2. Cosine rule, non-right triangle with 3 sides. Question. In triangle ABC, A equals 8, B equals 6, C equals 5. Find angle A. Step 1. Write the formula. By the cosine rule, a squared equals b squared plus c squared minus 2bc cos a. Step 2. Substitute numbers. 8 squared equals 6 squared plus 5 squared minus 2 times 6 times 5 times cos a. That is 64 equals 36 plus 25 minus 60 cos a. Combine terms. 64 equals 61 minus 60 cos a. Rearrange. 60 cos a equals 61 minus 64, which is negative 3. So cos a equals negative 3 over 60, that's negative 0.05. Step 3. Take arccos. A equals arccos of negative 0.05, which is about 93 degrees. Always include the reason. Cos a equals b squared plus c squared minus a squared divided by 2bc. That's your m1 and substitution m1, and the final a1 when you state the answer with a degree sign.
So for cosine, you get a direct angle from arccos. No ambiguous case here.
Correct. Cosine gives a unique angle between 0 and 180 degrees, because arccosine returns a single value in that range. Now, let's talk examiner expectations, so you can collect the marks every time.
Exam technique, what the examiner wants. For a typical 3-mark trig question, I'll say this: M1 for writing the correct formula, M1 for a correct substitution or rearrangement, and A1 for the final answer with appropriate accuracy and units. If you can't finish, write the formula and the substitution. You often bag an M1 or 2. So write by the sine rule or by the cosine rule clearly. Show the substituted numbers, show intermediate arithmetic, and write the angle with degrees. Don't skip the units. Examiners note degrees or degree.
On the ambiguous SSA trap, when using sine rule with 2 sides and a non-included angle, do 3 quick checks. 1. Compute the value of sine and confirm it's less than or equal to 1. If it's greater than 1, there's no triangle. 2. If it's between 0 and 1, compute the principal arcsine value. 3. Test the supplement, 180 minus that value, and check whether the sum of angles would exceed 180. Write those checks down. Even a short line saying check supplement can win method marks.
So writing your thought process out actually pays off. I always worry about losing time, but it's worth it.
Absolutely. Marks are there for the taking. Write it down, don't just think it. Now, your quick win. Quick win in 10 seconds. After you decide which rule to use, do a 10-second substitution check. If you use the sine rule, substitute your calculated angle back into the sine rule to recompute the known side. You should recover the original number approximately. If you use the cosine rule, use your angle and 2 sides in the cosine formula to check the squared relation roughly matches. 2 memory prompts. Opposite, sine. Included, cosine. Say them under your breath in the exam, and it cuts hesitation in half. Decision flowchart in words. Step 1. Label what you know. List known sides and known angles. Step 2. If you see angle and its opposite side, then consider sine rule. Step 3. If you see 2 sides and the included angle, or 3 sides, use cosine. Step 4. If it's SSA, check for ambiguous case immediately. Write your setup even if time is short. M marks are cheap to earn.
Can we try a short past paper style question together, so I can hear this live?
Yes, quick past paper style run. Question. In triangle ABC, A equals 7, B equals 9, and angle A equals 30 degrees. Find angle B and side C. Step 1. Label knowns. Angle A and side A are a pair, and side B is given, so this is a sine rule problem. Write, by sine rule, sin B over B equals sin A over A. Substitute. Sin B equals 9 times sin 30 over 7 equals 0.642857, so B equals arc sin of that, approximately 40 degrees. Now check supplement. 180 minus 40 equals 140 degrees, since 30 plus 140 equals 170, which leaves C positive. Both possibilities are valid. The exam usually asks for the triangle consistent with a diagram. If no diagram, you must state both or explain which you choose.
Next, find side C for the case B equals 40 degrees using sine rule again.
C over sine C equals A over sine A. First, compute C. 180 minus 30 minus 40 is 110 degrees. Then C equals sine 110 times A over sine 30. Sine 110 is about 0.9397, times 7 divided by 0.5 gives roughly 13.16. Write the numbers and you're rounding. That sequence, formula, substitute, solve, check, supplement, shows all method steps and wins marks even if arithmetic is imperfect.
That breakdown makes it feel like a recipe. Formula, substitute, solve, check. I can do that in exam stress.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find diagrams, worked solutions, and a downloadable checklist at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.